So the title of our project is to retrieve the descriptive text from the images, and I'm Weiguang. So as human beings, we can just describe different images with words, but it's hard for AI to do so, and there are already kind of billions of images in the internet. If we could make use of this amount of information, we could probably improve the performance of the AI. And so there are two main ways to tackle this problem. The first way is just to make use of the existing information and retrieve a whole sentence to describe the image. And the second way is just to build a sentence from the scratch. So in our project, we just follow the first way. And we are mainly inspired by the Kapasi's papers published in 2014. And so this flowchart shows the basic structure of our model. So given an image, we will use a regional convoluted neural network based on Café to detect the object embedded in the image. And we will design the mapping functions to project the image fragment to a kind of feature space. And also we will design another feature function to map the words of the sentence into the same feature space. After that, we can just calculate the similarity score of the sentence fragment and the picture fragment. And so we want to align the words to the close related bounding box or the image fragment across the different sentences. And this is called the local alignment. Also, we want to make sure that the image is aligned to the best descriptive sentence. And this part is called the global alignment, combined with the penalty term on the parameters, and we can just get our objective functions. So in our project, we just use a mini-batch stochastic gradient descent method to tune the parameters and the cross-validation to tell the hyperparameters. And so this is the basic flowchart of the image annotation process. So given an image without the labels, and we first use the RCN to detect the object embedded in this image, and we will filter the corpus we already have based on this kind of object. So in order not to miss any best descriptive sentence, and we also will include some kind of close related word based on some kind of similarity threshold. And use the parameters and mapping functions from the training process, we can just calculate the global similarity scores. And based on this kind of scores, we can just get the ranking list and output the top 5 or top 10 sentences to describe these kind of images. So this is kind of a detailed examples of our result. So below the pictures, you can show the top 5 sentences from our ranking list. And at the first place and the 5th place, it's just the best sentence to describe this kind of pictures or the ground truth. And we also show the words from the first sentence and connect them to the detections with the highly local similarity scores. And for this case, you can see that the boys, girls, and sittings are very well connected to the part of the image. And also, we show an example of the reverse process called the image search. So for this case, given the sentence that there's a white boat in the bay with a city in the background, and we can just output the top 5 images extracted from our database. So you can see that the first image just is the best image. So we run our batch test on 3 standard dataset called the Pascal 1K, Flickr 8K, and Flickr 30K. And the test of the Flickr 30K is still running, and we will provide the result in our report. And so there are many index or criterions to measure the performance of the different methods. So for example, the R at 5 means the percentage of the cases that we can find at least one sentence within the top 5 sentences in our ranking list. And so for this kind of percentage, the higher the better. And the mean R means the average position that we find our first best sentence in our ranking list. So for this index, the lower the better. So the number with bold number just shows the best result across all existing methods. So for this Pascal 1K dataset, we just do our best job, and we can just outperformance compare with other methods. So for the Flickr 8K, that we have the 6,000 images as a training set, and 1,000 for the validation, and 1,000 for the test. And for this case, we didn't do as best as the Pascal 1 case, but so the Kapasi's model do the best job. But it could be easily seen that our model is more or less at the same level, and we have a better performance at R at 10 and mean R. So these two kind of batch tests show the demonstrated that our model could handle this kind of images without any labels. And as the size of this set increase, and we can just get a better result. So, yeah, that's it.